Welcome, fellow engineers and IT enthusiasts, to a deep dive into modern deployment strategies. Today, we're tackling one of the most effective techniques for minimizing downtime and risk, blue-green deployments, powered by the incredible GitOps capabilities of ArgoCD. Imagine deploying a new version of your application with zero downtime, effortlessly switching traffic, and having an instant rollback mechanism at your fingertips. That's the power we're unlocking today. We'll explore how to structure your Kubernetes manifests using Kustomize, how a single stable Kubernetes service can act as your traffic router, and how ArgoCD automates this entire process based on changes in your Git repository. By the end of this tutorial, you'll have a clear understanding and a practical example of GitOps-based blue-green deployments on Kubernetes. Let's get started. Traditionally, deploying a new version of an application often involved a period of downtime, even if brief. Think about rolling updates. While they're great for incremental changes, a bug in the new version could cause widespread issues before all old instances are replaced. This is where blue-green deployments shine. Instead of updating instances in place, you deploy the new version, the green environment, entirely separate from your current, blue, production environment. Both run simultaneously, but only blue serves live traffic. This isolation allows you to thoroughly test green in a production-like setting before any user sees it. If everything checks out, you instantly switch traffic to green. If not, you simply keep traffic on blue and scrap green. It's a lifesaver for critical applications. The core concept of a blue-green deployment revolves around having two identical production environments and a stable entry point. The blue environment represents your current, stable production release. The green environment is the new, candidate release. Crucially, a single, stable Kubernetes service, often called a router service or load balancer service, acts as the unchanging entry point for all incoming traffic. This service's IP address and name remain constant, ensuring external consumers always hit the same endpoint. The magic happens when this router service's internal selector is updated. Initially, it points to the blue pods. When you're ready to deploy green, you update this selector to point to the green pods. This change is instantaneous, providing a near-zero downtime cutover. It's like flipping a switch, making traffic routing incredibly simple and reliable. Now, how do we automate this elegant dance of environments? Enter GitOps, a paradigm that uses Git as the single source of truth for your declarative infrastructure and applications. ArgoCD is the leading GitOps continuous delivery tool for Kubernetes. It continuously monitors your Git repository for changes to your application and infrastructure definitions. When a change is detected, ArgoCD automatically reconciles the desired state in Git with the actual state in your Kubernetes cluster. For blue-green deployments, this means we define our blue and green environments in Git. To perform a deployment, we simply commit a change to Git that tells ArgoCD to switch the router services selector. ArgoCD handles the rest, deploying the new environment, updating the router, and even cleaning up the old one, all driven by a single Git commit. This makes your deployments auditable, repeatable, and fully automated. Let's break down the project structure that enables this. Our demo repository is organized into several key directories. The argoct folder contains the ArgoCD application definition, which tells ArgoCD what to deploy and from where. Then, we have the Kubernetes directory. Inside it, Kubernetes/base/ holds the core, generic Kubernetes manifests for our application, the deployment, the service, the router service, and the ingress. These are the building blocks that will be customized. Finally, we have Kubernetes/overlays/. This is where the magic of Kustomize happens, with subdirectories blue/ and green/, each defining environment-specific configurations. This structure ensures reusability of base manifests and clear separation of environment-specific details, making our GitOps approach clean and maintainable. Deep diving into the Kubernetes/base/directory, you'll find our foundational Kubernetes resources. We have a generic deployment.yaml for our application, myapp, which serves as a template. It defines placeholders for things like the image tag and environment-specific messages. Similarly, service.yaml defines a generic Kubernetes service for our application pods. The truly pivotal component here is routerservice.yaml. This is our stable entry point, myapp router service, which external users will always hit. Its selector field, however, is a placeholder. It's designed to be dynamically updated to point to either the blue or green application pods. Finally, ingress.yaml provides external access to our myapp router service, ensuring traffic flows smoothly from outside the cluster to our stable router. These base manifests are the common blueprint for both our blue and green environments. The cleverness of our blue-green setup comes alive with customized overlays. In Kubernetes/overlays/blue/ and Kubernetes/overlays/green/, we use customize to specialize our base manifests for each environment. Each overlay applies a name suffix, like blue or green, to the deployment and service resources. So, our base myapp deployment becomes myapp blue or myapp green. Within each overlay, deployment.patch.yaml specifies the unique image tag and a specific message for that environment, for example, hello from blue environment. Version 1.0.0, or hello from green environment. Version 2.0.0. Crucially, service.patch.yaml updates the application service to select the correct pods, e.g., version, blue or version, green, and router service patch.yaml is the real star. It patches the stable myapp router service to change its selector to either version, blue or version, green. This single patch is what switches traffic, making the router dynamically point to the active environment. Central to our GitOps workflow is the argoc/application.yaml file. This manifest tells ArgoCD everything it needs to know to manage our blue-green deployment. The source.repo URL points to your Git repository, and target revision specifies which branch or commit ArgoCD should track. The crucial part for blue-green switching is the source.path field. Initially, it's set to Kubernetes/overlays/blue, instructing ArgoCD to deploy and maintain the blue environment. When we want to switch to green, we simply change this path to Kubernetes/overlays/green in Git. ArgoCD also uses a sync policy with automated, true, self-heal, true, and importantly, prune, true. Prune, true is vital for blue-green. When the path changes, ArgoCD will automatically detect that the old environment's resources, like myapp blue deployment and service, are no longer part of the active customize overlay and will gracefully remove them, ensuring a clean state and preventing resource clutter. Let's walk through the initial deployment. Once you've cloned the repository, set up your ArgoCD, and ensured argoc/application.yaml points to your Git repo with path, Kubernetes/overlays/blue, you simply apply this ArgoCD application manifest to your cluster. You'd run kubectl apply f argoc/application.yaml n argoct. ArgoCD, constantly monitoring your Git repository, will detect this new application. It then proceeds to create the blue-green demo namespace, if it doesn't exist, and deploy all the Kubernetes resources defined in the Kubernetes/overlays/blue customize output. This includes myapp blue deployment, myapp blue service, and it configures the myapp router service to direct traffic to the myapp blue pods. You'll see blue-green apps sync and become healthy in the ArgoCD UI, indicating your blue environment is live and serving traffic through your stable ingress. Now for the moment of truth, seamlessly switching traffic to the green environment. Imagine you've developed and tested a new version, v2.0.0,